Alright, I have some corrections to do on the test prep, so I'm going to do them. So I'm going to do 50, 51, 52 again with you. So if you see the answer key, compared to what I'm doing, this is why this video is there, to correct some things like that. So step one here is to factor. Let's hope I can factor correctly. So negative 12, that's going to be negative 4 and positive 3. I don't believe I factored correctly, and if you factor wrong, everything else is going to tumble wrong. Already I know the domain is x can equal 4 and negative 3. I know there's one x-intercept at negative 2 and it's odd. If I plug in 0 for x, I get negative 1/6. That's the y-intercept. It's 2 over 12, and that's the same as 1/6. Asymptotes, I have 4 and negative 3. They're both odd. And the horizontal, because the bottom is more powerful, it's 0. There is no hole. And the end behavior is as x approaches infinity, f at x is going to approach 0 from both sides. So both positive and negative infinity for x, the function is going to approach 0. So the horizontal asymptote gives you that end behavior. To graph this, we'll start at 4 and negative 3. We have no holes. We have a horizontal asymptote at 0, so I'll do that one. There's 0. We have a intercept at negative 2 and at negative 1/6. And there we go. So we'll start there. I know it crosses over, so I already have the pattern of that. It's going to go to the vertical asymptote. So this side is going to go to negative infinity, and the other side is going to go to positive infinity as it crosses over. I need a point on the other side, so I'll plug in 5 or 6. Here, let me plug in 6. I think it'll give us a nicer point. So 6 plus 2 is 8. 6 take away 4 is 2. 6 plus 3 is 9. So 8 gives me, or 6 gives me the point 1/2. So I'll put that there. So I know it's going to go to infinity, and then it's going to follow the horizontal asymptote. On the other side, if I put in negative 6, I get negative 4 over positive 30, which is negative 2 over 15. If I put in negative 5, why did I put in negative 6? It's negative 3, right? I could put in negative 4. So if I put in negative 4, I get positive 1/4. Oh, what am I doing wrong? Negative, that's a negative, isn't it? See, even my correction, right? So there. And I knew it was wrong because I knew that this is an odd vertical. One end is up and the other end is down. One end is down, the other end is up. So the pieces have to match. So if I make a silly mistake with a sign, I can double check to make sure that I'm doing it correctly. All right, number 51. Again, let's see if I can factor correctly. So the top is positive 3 and negative 2, and the bottom is negative 4 and positive 3. Sure, yes, yes, no, no, yes. So right away I know the domain x can equal 4 and negative 3 from the denominator. I remove x plus 3. So that means there's a hole at negative 3. To find the y value of the hole, I plug negative 3 into what remains. And I get positive 5 over 7. I think I might have done this one right. The intercepts are on top. It's just positive 2 for the x-intercept, and it's odd. For the y-intercept, put in 0, and you get 1/2. The asymptotes, there's one at x equals 4, and another one. If you divide the power terms, x squared divided by x squared, you get 1. So at 4, we have a vertical. At 1, we have a horizontal. And we have a hole at negative 3. and 5/7. So let's fill in some other things. We have a y-intercept and an x-intercept. And you can see how the hole and the 2 points guide us into the curve. So at the vertical asymptote, it's going to negative infinity. The left end behavior in the right goes to positive 1. So both sides go to 1, left and right end. Here I just need a point over here, so I'll use 5. So 5 take away 2 and 5 take away 4. So that gives me 3. So at 5 it's 3. So I know it goes to infinity and then the end behavior. Alright, one more that I may have done wrong. In fact, this one I know I did wrong on the first one. So let's make sure I factor correctly. Plus 2 and minus 1. So it means there's no hole. The domain x can't equal negative 1, and that creates a vertical asymptote. The intercepts are at negative 2 and positive 1. And if I plug in 0 for x, I get negative 2 as well for the y-intercept. So we'll start there. We also need to find the oblique. So negative 1, negative 2, and negative 2. And positive 1. Alright, to find the oblique, we're going to use synthetic division. So negative 1, the 0 of the denominator, then 1x squared, 1x, and negative 2. Drop down the 1 and then multiply. That's all I need. I don't need the remainder. So it's y equals x. So start at 0, up 1 over 1. Take a 45-degree angle asymptote. And now we have points on both sides. So we know it goes to negative infinity and then follows the oblique. Goes to positive infinity through the point and then follows the oblique. So in this case, as x approaches infinity, f at x on the right end behavior goes to infinity, and on the left end it goes to negative infinity. So the end behavior is going to either follow the horizontal, and if there's no horizontal, it follows the slanted line, and one end goes up and the other end goes down. All right, those are my corrections. So I hope that clarifies it, and good luck on your exam.